Molecules, here's the definition that we need to learn. Only nonmetals and metalloids form molecules. We know an atom is just one particular element. When we're talking about molecules, we're talking about when nonmetals are either bonded with themselves or with other nonmetals and metalloids. Molecules are slightly different than compounds. We can say all molecules are compounds, but not all compounds are molecules. When a metal bonds to a nonmetal, we get electrons being transferred, ions being formed, and those are compounds when they bond together. They are not considered molecules. So we're not going to say, or we're going to say we have a molecule of water because we have two nonmetals bonded together, hydrogen and oxygen. We're not going to say we have a molecule of salt, sodium chloride, because we have a nonmetal bonded to a metal. There's 7 diatomic molecules. All right, they actually form what looks like a 7 on the periodic table. By starting with nitrogen, moving along oxygen, fluorine, chlorine, bromine, and iodine, and don't forget hydrogen. What it means that they're diatomic is whenever they're found in nature, they always have a buddy. They're always bonded with one of themselves. So if I say you have a sample of nitrogen, that I'm saying you have N2, nitrogen bonded to a nitrogen. If I say you have some iodine crystals, that is just iodine, which is I2, 2 iodines bonded together. It doesn't matter really the state of matter that they're in, solid, liquid, or gas. If it's just nitrogen, it's N2. If it's just chlorine, it's Cl2, and so on. An ion, the definition of an ion is when an atom or a molecule has either gained or lost electrons. Cation is a positively charged ion. The way that I remember it is that the T in cation looks like a plus sign. Can't forget that. And an anion is negatively charged. So if you've gained electrons, you're an anion because electrons are negative. If you've lost electrons, you're considered a cation because you're positively charged. Some simple formulas here, molecular formulas. All right, we don't reduce them, basically, is what we're saying. So like H2O2 is hydrogen peroxide. We don't reduce that down to HO. For ionic compounds, we would. We wouldn't say Ca2S2. We would just say CaS. So it's the simplest ratio when we're talking about ionic compounds, but for molecular formulas, we leave them in their whatever their formula is. Here we have for our ions, when we know the charges, we can do the old switcheroo. You guys should have done this a lot, or done this freshman year. We see here in our first example, we have sodium and the sulfide ion. Na is +1, sulfur is -2. We switch them. So the 1 here, we drop the sign, comes on the outside of the S. The 2 comes on the inside. So we're saying here we have 2 Nas for every 1 S. Calcium and chloride, same idea here. The 2 goes to the outside with the Cl. The 1 comes to the inside with the Ca. We don't write the 1s. So we have 1 Ca for every 2 Cls so that the charges balance out. Aluminum oxide, Al2O3, the 2 from the charge of the oxygen comes in, 3 from the charge of the aluminum goes to the oxygen. All right, I'll give you a couple seconds. Try these simple 3 examples. All right, so for the first one, we see that there's a charge of -3 on the P. So that's going to come in. So it's just going to be K, 3P. Hopefully you can read that. This one, we have Zn as +2, N as -3. We do the old switcheroo. Zn3, N2. And our last one, Ca +2, S -2. If they are the same charge, we don't worry about it. We don't even have to do the switcheroo. We just write CaS. Very important, if the charges are equal, we don't do the switcheroo. If the charges are unequal, if they're different, then we do the old switcheroo.